Twinkle, twinkle, little star, how I wonder what you are. Good day, Mr. Jimmy and my fellow classmates. Thanks for having my group here, which consists of Mr. Wong Yi Sen, Mr. Teo Ze Jun, Miss Chow Yi Yan, Miss Jia Xuen, and Miss Siaw Tze Wei here. Our topic here today is about star life. What is star life? Star is a luminous ball of gas, mainly hydrogen and helium gas, held together by its own gravity. But how does it glow? Let me tell you. Inside the core of luminous ball of gas, there is a chemical reaction occurs called the nuclear fusion reaction to support the star against its own gravity. While produce heat and light, which call electromagnetic gravity or even photons. What we see the stars in the sky is a tiny dim light. However, the stars are actually way more enormous than our Earth and hotter than a volcano. There's a fun fact of the star. The colors of the star in the space differ from red to yellow to blue, just like a fire. This is due to the temperature of light, which lower temperature emits warmer light, which is red color, while higher temperature emits cooler light, which is the blue color. Now I'd like to pass the time to Chow Yi Yan.
In ancient times, the stars and planets were used to tell stories based on the shapes of constellations in the sky in ancient civilization. The stars resemble people, objects, and animals at times. These astronomical observations and stories were carved in the stonecraft for over 30,000 years. Besides that, ancient people used stars and planets to determine their global location. Certain constellations, such as the Big Dipper, could only be seen from the north of the sky, according to astronomers of the time, and knowing this allowed ancient sailors to navigate at sea. A famous Italian astronomer, Galileo Galilei, learned about the Dutch perspective glasses in 1609 and designed his own within days. He improved his creation and was able to magnify objects 20 times. He was the first to use a telescope to look up into the sky. He was able to view the mountains and craters on the moon, as well as a ribbon of diffuse light arching across the Milky Way. Moving on, let me briefly talk about previous stage of molecular cloud. Molecular clouds, the coldest and denser clouds in the interstellar medium, are mainly made up of dust and gas in the form of hydrogen molecules. A molecular cloud can mass from a few to over a million solar masses and a diameter from 20 to 200 parsecs. It has a temperature of about 10 Kelvin and a density of up to 102 particles per cm3. Based on observations, stars are mostly formed within molecular cloud, which are mainly located in the disk or spiral galaxies and the active regions of galaxies. In addition, let us move to previous stage of protostar. The molecular cloud begins to spin as it collapses, and by the time a protostar is formed, the cloud has been demolished and a protostellar disk is spinning around it. These disks are thought to slow the protostar's rotation and occasionally condense into planetary systems. The protostar produces a powerful magnetic field as it rotates. A strong protostellar wind, which is an outward flow of particles into space, is also generated by the magnetic field. That's all from me. Thank you. Next, I'll pass to Ethan.
When it comes to a red dwarf stars, a small red planet may be visualized in our mind. The mass of a red dwarf ranges from 8% to 50% of the Sun, and they are the smallest stars in the universe. Due to their dwarf size, the consumption of energy to burn hydrogen and shine is very low compared to the other stars. This shows that why red dwarf has a lower temperature and has enough energy to sustain themselves for almost 10 trillion years. Just in the Milky Way alone, red dwarfs make up the largest population of stars, and scientists predicted that almost 65% of the stars near the Earth are red dwarfs. Yellow dwarfs are the medium-sized stars belonging to the mass sequence that weighs between 0.7 to 1 solar masses. They have a surface temperature between 5000 to 6000 Kelvin and shine in yellow-white color. Yellow dwarfs make up 10% of all the stars in the Milky Way, and our Sun is considered one of the yellow dwarfs. When a yellow dwarf has ended its life due to the exhaustion of hydrogen, the fusion reaction of helium will take place and the yellow dwarf will become a red giant star. Blue giant star in luminosity class 2 and class 3 has a temperature of 20,000 Kelvin, while blue supergiants in luminosity class 1 can reach even higher temperature, about 50,000 Kelvin. They have luminosity that are 1 million times brighter than the Sun. Blue supergiant stars are the most massive stars in the universe, which can exceed 25 solar radii and 20 solar masses. Due to the blue supergiants having an extremely high masses, their hydrogen fuel will be burned off around 1 million years and have an age of less than 10 million years. Even though blue giant stars are the rarest in the galaxy, but most of the brightest stars still belong to blue giants.
Well, that was very entertaining from Yi Sen. From main sequence stars, they turn into old stages. So what would you do if you return into old age? Well, red giants are stars formed from some of the low to intermediate mass main sequence stars, with around 0.55 solar masses. The core of the red giant undergoes nuclear fusion, a convergence of hydrogen and helium atoms, until the core is drained of the atoms. As time goes by, the temperature of the star drops drastically and coming with the color red. Well, there is a fun fact I ought to let you know. They only spend 1% of their lives as a red giant. They're around 100 to 1,000 times bigger than our Sun as of now. Additionally, they are approximately 2,400 kelvins to 3,400 kelvins. Then, there is the red supergiants. They are known as the eldest and the most massive star amongst the old stage stars. Some of the well-known red supergiants like VY Canis Majoris, MU Cephei, and KW Sagittarius have radiuses 1,500 times bigger than the Sun. They generally are the biggest stars, but they can't last long enough. Only about a few 100,000 to a million years old. While they are basically like red giants, which means they undergo nuclear fusion, but this process is non-stop and occurs until iron forms in the core of itself. Next, they face their own dying stages.
Hi, my name is Jia Xuen and I'll be talking about the death stages of stars. Starting from a white dwarf, white dwarfs are also known as the corpses of stars. They can exist for a very long time because they require billions of years to transmit their heat to their surrounding through radiation. During the formation of white dwarfs, the density of white dwarfs remains almost the same as its former star density. And also, it is a very dim star as it shines white instead of bright red. Next is a nebula. According to the Latin definition, nebula is formed from 5 elements, which are mist, vapor, fog, smoke, and exhalation. Hence, they are created either by a cloud of cold interstellar gas and the dust of the remnants of a supernova. Lastly, we have the supernova. There are 2 types of supernova. The first one develops in a binary star system when 2 stars orbit at the same position. The second type of supernova happens when a star dies and is no longer able to support its own gravitational pull. Many scientists believe that some elements found on Earth are products of the explosion of a supernova that contributes to the formation of new planets and stars.
Thank you, Jia Xuen. Now has come to the remnant stage of a star. First is the black dwarf supernovae, which will thereafter be mostly empty and near the absolute zero in temperature. When a massive star runs out of fuel and collapses, a neutron star is formed. If 1 to 3 solar masses are in the core of collapsing star, a newly created neutron star can stop collapsing and leave it behind. Pulsars and magnetars are the example of neutron star. First, pulsars are the rotating neutron stars that emits radiation in an extremely short time interval. It has extremely intense magnetic fields to accelerate particles, jets out along the 2 magnetic poles, producing extremely powerful light beams. You could also think about it like a lighthouse which shines beam of light across the sky at night. On the other hand, the magnetar is another neutron star that has magnetic field trillions of times stronger than the Earth. Finally, a common term to all of us, a black hole. An incredibly dense cosmic mass which literally nothing can escape, not even the light. How does it form? Let me tell you. The core of the massive star's internal thermonuclear fields are depleted. The core becomes unstable and gravitationally collapses inwards while taking off the outermost layer. This causes the weight of component matter falls incredibly and being compressed into a singularity, which is a point of zero volume and infinite density. More details about this could be determined by the Albert Einstein's general theory of relativity. Singularity, which I mentioned just now, is the center of the black hole and is covered by the event horizon, which is the object surface. Inside the event horizon, the speed needed for matter to escape from a cosmic object's gravitational field surpasses the speed of light. This is why not even the light can escape into space. Black hole is extremely hard to observe. However, we could locate it by the effect of its neighboring matter, which is by observing through the effect of the massive gravitational fields of the neighboring matter. Now I'd like to pass the time to Tze Jun.
Well, thank you for that, Jane. Well, it was quite a journey from the introduction to the background and to the life cycle of stars. In the intro, we learned that stars are not just balls of fire, and in the background, we know that Galileo Galilei is a true scientist. And since for the life cycle, we know that 5 stages, which are the pre-birth stage, the birth stage, the old stage, the death stage, and the remnant stages, are the life cycles of a star. Well, what if the sun exploded on the next day? Well, this may sound like a terrible thing at this point, but believe it or not, if it were to explode on the next day, the resulting shock wave will not be able to destroy the entirety of Earth. Only the side facing the sun will be disintegrated and the sea boiled into oblivion. But on the other side of the Earth, mankind would experience a rise in temperature 15 times of the sun's surface and would probably burn away every possible living thing in the other hemisphere. There will be nothing left to gravitate to the solar system, and every planet will be spiraling out of control. Eventually, the sun will die, and it is only a matter of time before it happens. But what if we were to survive this? Well, the key, which I believe, is to transfer to another solar system, which contains a sustainable star that is able to provide for livable planets that can hold another race of humans and animals. Research from years ago has found a handful of planets outside of our solar system that is almost similar to our Earth. From food to water to oxygen and other living needs are readily available to us. But the problem is, the journey to the planets is extremely far from our planet Earth. Well, there is one habitable planet which are found by scientists, which is Gliese 667 CC. It is a triple star system in the constellation of Scorpius at around 22 light years away from Earth. To conquer this issue, all we have to do at first is to build a spaceship and travel there in a spaceship with interdimensional traveling tech. It will be so insane yet stupendous. Think about the new ship that travels tens of light years per hour without ripping our face off into oblivion is what's needed now. And now for the vision, we would hope that the solar system does kindness to us and the fate of humanity is saved from extinction. Thank you